हरिः कन्ना।
Now let's look into the third one. It's a deep copy. So the copy method makes a complete copy of the array and its data. So that's what we're going to see. We have seen a shallow copy or view or shallow copy, and we also seen the first one. So now we are going to see a deep copy. Okay. So the third one is deep copy. Let's take D and then same array, and we'll use the copy method. So here a new array object with the new data is going to be created. So D, let me check D now. So print, you see that exactly it's A. And now let me say D is A. Yes, it's false. D is not A. Why? Because D, let's check D dot base is A. Now let's check other one. D dot base is A. D does not share anything with A. That's what I'm saying. The complete copy has been created. So now you have a D variable, A variable, and similarly you have this object is located at certain memory location for A as well as for D. So there are two objects and then two variables. That's what we call it as a deep copy. Okay. So now let me add D of 0 comma 0. So let me add at that place I want triple nine, sorry, 4 nines. So now let me check D. Here is that location 0 comma 0. It's a first row, first column. Triple nine, 4 nines has been added. Now let me cross check with the A. What's going to happen for A? A object, no change. That's what I'm saying. So if you are unable to understand this, then you have to visit my intuitive Python for you course. I have explained this concept of variable assignment very clearly. So what happens in Python when you assign a value? For example, now if you take this is an object, it's an int object, and this is a variable. Let's remove this. Okay, let me write down at this point. When I say x is equals to 10.0, so what is this 10.0 or 10.0? Is a floating point number, correct? So floating point number is one object. So this object will be located at, for example, at 0 x and some number. Okay, this is the location of memory location of object. That's floating point object. Now where will the x be stored? X will be stored at some other location. Let's take x. Okay, this could be the x location. So this is the memory location of variable name. Okay, this is called variable name. These are called names in Python. So the variable name was located at some location, and then object was located at some other location. When it comes to the first case, what happens? The first case is no copy at all. In no copy, what happens is you will have two variable names x and y, but object will be one. So this both will be sharing this object. Okay, that is one case. It's called, this case is called no copy at all. Okay, and we have the second case. It's a view. So view is basically the slide view. When you do changes in the view, that will be reflected in the original object. And the third one we have is copy, a deep copy. Let me write deep copy. So for deep copy, we'll use a method, copy method. In this method, what happens is, so now you have x, a variable name will have a separate object. For example, you are using the same object 0 0, this object, the object remains same, object 1. Okay, let's take that as a object 1. So object 1 remains same, but the location will be varying. So object 1 at location 1, and y object remains same. What is that object? 10.4, but object 1, but location would be different. So like that, so x will have object 1, y will have an object. So that's the reason when you do changes, when you do changes in y, it will not, it will not be reflected in x object. Simple. Because the object, though the copy is created from x, but it's going to create a separate object at separate location for the variable name y. That's what I'm trying to tell you, and that's what I'm trying to prove here. I hope you got it here with this. See, D array, I have done changes to D array object, and there is a change in D array object, but in A array object it's not changed, because these are the two objects which are stored at different locations, though it was copied, the D array was copied from A. Now let's get back to the slide. So sometimes copy should be called after slicing if the original array is not required anymore. For example, suppose A is huge intermediate result and the final result B only contains a small fraction of A. A deep copy should be made when constructing B with slicing. So let's get, yeah, let's do this, a second example. So this one I'm converting into M, and let me execute. Yeah, clear. So now let's take another example. This time a new array np dot a range, and inside that I'm gonna take int of le8. Sorry, that's my mistake. It's 1e8. So a, yeah, you got it, 1e8, and this is what the values of array A. So now what I'm gonna do, b is equals to a of colon to 100, and then I'm put the copy. So basically I'm copying that to b. So now let me check the b. So you got the huge one. This is absolutely second object with a slight modification. Though you have copied it from a, you can see completely different one. So now what I'm gonna do is I'll say just del a. So this, the memory of a can be released with this. When I say del a, the memory of a can be released. So now let me check here. It's gone. A is removed, the name, because I was telling you the same. I just released A from the memory. So no more A. This is what A will be stored at some location. Now I released A from that memory, then you can't find any memory, anything but the object stores. Because it's just a referencing this variable name with certain object which is stored in some other location. That's it. Pretty simple. The concept is pretty simple. So now if I say, so if b is equals to a of colon 100 is used instead, a is referenced by b and will persist in memory even if till a is executed. Okay, so let me say b is equals to a and colon and 100. So of course a is not there, so we cannot do it now. So you have to create a once more, just go up and then mm, go up and then execute the a and recreate and re-execute it. That's it, it will be working.